So now that we've explored many of the attacks on features of GraphQL and some of the mistakes in design and development that are easy to make, we need to look at how we can use it as a vector for other attacks and more common things like injection, cross-site request forgery, XSS, etc., etc. And in this section, we won't go deep into how these vulnerabilities work because one, it's likely that you already have a good understanding and experience with them. But we want to look at how we can test for these in the context of GraphQL applications and highlight any changes that we might need to be on the lookout for given the context of our app. So let's dive into some examples of our usual attacks on web apps via GraphQL. And first up, I want to take a look at injection attacks. So if we just spin up our application and spin up Burp Suite, and then open the browser, and we'll just start exploring our application as usual. So here we can come alex@alex.com, password, like this. All right, so let's create a server quickly. And then we can just do test, for example, show invite link, regenerate, create room. Let's call this room 2. And now we're ready to start exploring our application. So let's come back to Burp Suite. And of course, I think the easiest way to do this when in GraphQL is instead of going through each request and kind of sending them to repeater and exploring them further, we can of course come to the targets and we'll come to GraphQL, and then these are the queries that it's already picked up on. And we could also do our introspection and add more queries to this, but I think this is a good place to start. And sometimes introspection won't be enabled, so this is a good starting place where we click on everything in the application, we do every action, and then we review those one by one. Now, with GraphQL, what we want to do is find places where we can inject data. So, of course, if we come over here and come to our GraphQL scanner tab, unfortunately, another fun quirk of Burp Suite is that if this is cut off, you can't click on it. So, for example, if you're having trouble clicking here, it's not going to work. Just another fun bug in the Burp Suite UI. And what we want to do is mostly pay attention to variables. So here where we have the server ID, here where we have the name, can we inject into these? And of course, every time the application interacts with the database, we should be testing for SQL injection. And every time that our input is reflected in the response, so for example, here we have Alex's server and it's here in the response, and we can also see it on the page. We want to test for things like cross-site scripting, server-side template injection, client-side template injection, etc., etc. And one of the ones that I want to show you, which is an issue that I found across quite a few different applications, because I think this is quite an obvious place for cross-site scripting. This is a nice little test to see whether we can get cross-site scripting, but obviously engineers these days are generally a little bit more aware of these types of attacks, so I think the obvious places generally get protected, and also a lot of applications undergo web app pen testing or bug bounties, so if this was vulnerable to cross-site scripting, it would be found pretty quickly. But a nice stored cross-site scripting that I've found a couple of times is on things like sign up, or especially when you have the ability to sign up an account through a third party. So for example, if you could sign up to Google or a different service, and then you put your payload there, and then of course use that account to access the application. The application trusts the input that's coming from the third party, and then we can execute our payload. But in this case, all I'm going to do is take a look at the sign up field, and let's come into here and let's try and drop in a simple payload. So source equals X, on error equals prompt, like this. And let's change this to test@test.com. And we get a token, and all I'm going to do is sign out of here and sign into test@test.com. like this, and we have cross-site scripting. So one thing to remember is that when we're intercepting traffic, often things will be encoded, or there might be some client-side protection. So for example, if we did this through the UI, maybe it's going to change this to like and less than, for example, and greater than, for example. But of course, in the proxy, we could easily overwrite this and just change it. But here we can see that we can achieve cross-site scripting quite simply. So many attacks in the context of GraphQL are the same, doesn't really change them. All that changes is where we're injecting or where we're putting our payload so that the application processes it. And that's the main thing to remember when testing any application that uses APIs. It's going to be susceptible to any attack that is available for web applications. It's just our delivery method might be a little bit different. All right, so next let's talk about cross-site request forgery, which requires a number of things to be able to pull off in GraphQL. And with our application, we're running Apollo server, which by default has cross-site request forgery protection unless we specifically disable it. Coupled with the fact that we're not actually using something like body parser within our application. So this is a Node application, but if we wanted to send a xwww form URL encoded request, we'd actually need to install the library and do something like const body parser equals require, and I think it's body parser like this. And we'd have to make our application specifically able to deal with it, and then of course enable it in Express as well. Aside from this, we're using JSON web tokens, which are being passed as the header rather than cookies, which basically means that we really need to go out of our way to make this application vulnerable to cross-site request forgery. Now, if you want to know more about cross-site request forgery protection in Apollo server, we can have a look at the documentation, and I think I have the link in my notes. And what I recommend is that if you're working with a particular technology, like all the time, or maybe your organization uses a particular tech stack, then go deep into the technology's documentation. But of course, if it's just a one-off pen test, then you probably don't want to spend a whole day just reading documents. But for me, for example, if I'm building a GraphQL application, I will probably always use Apollo. And so going through and reading the documentation is an important part of that. So even though our application isn't vulnerable to cross-site request forgery, I still want to demonstrate these steps for pulling off an attack for CSRF within GraphQL to you. So what we're going to do is we're actually going to use a Portswigger lab for this demo. And of course you can follow along too, since it's free to sign up and access the lab. So let's go ahead and do that now. All right, so here we are at the lab, and this one is called Performing CSRF Exploits over GraphQL. And I wanted to show you this one because it does have a couple of particular steps when it comes to GraphQL to exploits. So if we come to Burp Suite, and you'll notice that I've actually switched to Burp Suite Pro. And this is just because I wanted to use the POC generator within the engagement tools, but we'll see how we can do this without that as well, just by creating a simple HTML form. And what I want to do is come into here, and of course, first up with any CSRF, we need to find a non-public facing form or form submission that has some kind of impact. And let's just test this. So if we do, in fact, actually, let's keep the original here and just test this to Vino1. We can update the email and we can see that this is indeed Vino1. And then we can come to Burp Suite, HTTP history, and have a look at the mutation. So here we have mutation, change email, and then we have the email input. And of course, if we switch to GraphQL mode, it's a little bit easier to read. And the input here is what we want to change the email to. So if we look at the request, I don't see any CSRF token, which is nice. And let's just send this to Repeater to start working on this. Now, to get CSRF to work, what we actually need to do is we need to send an x form URL encoded request. And that means we need to change the format of our body as well. So to do this, very quickly, all we need to do is copy this. And in fact, I'm just going to send this to repeater once again so that we have the original copy. Of course, we can click send and go back and forth between. But let's work on this one for now. And I'm just going to change the request method twice, and you can see here we have application x form URL encoded, and here we have a post request, and what we want to do is rebuild our payload. So we can copy this, and what I usually do is I haven't found a good tool that changes from this JSON query into a form URL encoded format. So what I've done is if I just pull up Visual Studio Code, I recreated the query in that format. So you can see here, this is the original query. We can do things like get rid of this opening quote and then get rid of these, and then also drop like the break line and the spaces and go through. And this is essentially the query in kind of a nicer format. So we've got query equals mutation change email, and then we've got change email and the variable and the email, and then the operation name, change email, and the variables at the end. And this is it all on one line. So if you want to do this manually, you can obviously do this manually, but what I recommend is throw your payload into ChatGPT and say, hey, I need this in the form URL encoded format, and it's probably going to do it for you or get you very, very close. And I would always double check the output of ChatGPT, but if you're not familiar with converting this manually, then that's the way to go. But anyway, I'm going to just copy this, come back to Burp Suite, and then we're going to try and verify if it works. So let's paste this in here. And we know that currently our email is set to vina1@normaluser.net. And then if we send this, we get a response saying alex@alex.com. And if we refresh the front end, we do indeed see that we can update the email address. So it looks like we can also reuse the session cookie as well. So we don't need a new cookie each time, which would also prevent us from achieving cross-site request forgery. So next, what I'm going to do is I'm actually just going to change this into a plus and just make sure that this is still working okay, because I think that might impact the final payload. And what I want to do next is come to engagement tools and generate CSRF POC. Now, this is the part where you can't do this on the community edition of Burp Suite, but what you can do is just HTML body, create a form, put the action on where to submit it, and then in here you just have the fields that you want to submit. So this isn't a super complicated form. Of course, this has just been encoded, and you could create this, or once again, you could drop this into ChatGPT and say, hey, please create me a CSRF POC. So let's just close this quickly and let's change this to something like 99, and engagement tools, generate POC, test in browser, copy, close, come to the browser, paste, and then if we come back to here, we can see that our payload did indeed work, which is great. Now, I'm not sure if we need a particular email address to attack Carlos, but let's give this a try. So generate POC, copy HTML, and then we'll come back to here, go to exploit server, drop this in here, store, and deliver it to the victim. And it looks like that hasn't worked. So what I want to do now is probably just encode everything to make sure that nothing's breaking. And we need to get rid of this encoding, otherwise it's going to double encode that space. So let's select these and quickly convert selection, URL encode all characters. Let's do the same for this. And let's do the same for this here. And that still looks like it's working. And then in here, engagement tools, copy HTML, paste this in, store, and deliver to victim. And fingers crossed it works this time. And there we are, we managed to solve the lab. So as you can see, sometimes we need to go through some extra steps to get an exploit to work, but GraphQL is just another layer in the tech stack, and therefore your methodology should be tailored to, but not entirely defined by GraphQL. And if you completely focus on GraphQL, you'll miss out on our usual attacks like server-side request forgery, but then if you ignore GraphQL entirely, then you'll miss out on information disclosure and broken access control and batched queries, etc. etc. All right, I will see you in the next video.